Hey, ladies and gentlemen, today you're going to learn how to construct a one sample t interval for mu. What I'd like to do is I'd like to get familiar with your formula sheet right now because it will come in handy in case any test anxiety pops up on that AP test. You want to make sure, how can I make this formula sheet work for me where it's actually helping me? Okay, so we're going to look at that formula sheet right now. If I go ahead and I look at my formula sheet and you're asked on the test, construct a confidence interval, and you're like, oh my gosh, wait, how do I do that again? Okay, so most things are on here for you guys that will really help. If I go up here on page, I think it's the first page here, I can see I have my confidence interval right here. So I need to take my statistic plus or minus my margin of error. My margin of error is that critical value. So in the past, it's been Z star times the standard error of the statistic. So what we've been using is that proportion, that p hat times 1 minus p hat over n, take the square root of it. Well, today what we're doing, guys, is we are actually doing a one sample t interval for mu. So what we're trying to draw conclusions about the population is not for a proportion, but for a mean. We want to find the true mean of a population instead of a true proportion of a population. So what statistic am I going to be using? Well, in this case, I'm going to take a sample and I'm going to get an X bar plus or minus the critical value, and I'll talk what that is. But I'm going to talk about the standard error first, times the standard error. Keeping in mind, guys, that this right here, this is my margin of error. Okay, don't forget that. Okay, now let's go and let's look at our formula sheet. We want the standard error of a statistic. Well, now my statistic is a mean. You can see here, we have the sampling distribution for proportions where they give you what your center is of your curve, your standard deviation, as well as the standard error when we're using that confidence interval. Now we're dealing with means right here, okay? So it outlines it there for us. You have to ask yourself, am I dealing with a one sample or a two sample? And I am dealing with one. And then I need that standard error of the statistic as defined on my formula sheet. And that standard error of the statistic is S over the square root of n. So let's write that down now. I'm going to write it down just a little bit different because how you learned a sample standard deviation, meaning a standard deviation that's describing a sample, how you learned it as S of x. So S of x over the square root of n. Now we need to talk about the critical value. The critical value, okay, I don't want to do that. Okay, the critical value for us used to be our Z star because we were dealing with the Z distribution. Now we're moving on to the T distribution. So we're going to be looking for a T star. We use the T distribution when we're talking about means in AP statistics, and we use the Z distribution as we're talking about proportions. That's a common question. How do I know when to use a Z versus a T? A T is for means, a Z is for proportions. I'll talk more about that in my next video as well. Now I want you to also get familiar with the formula sheet on how do I find this T star. So we're going to practice, okay? We're going to practice. Let's go ahead and let's go back and look at the formula sheet. Let's first talk about where our Z stars are. Our Z stars are on table B again. And if we look, right here, guys, these are all our Z stars. Here's our confidence level. So if we had to construct a 95% confidence interval for P, we go to 95% and our Z star is right here. Or our 99% confidence interval, our Z star is right here. Up here, guys, these are all our T stars, not our Z stars, our T stars. Now you'll notice over here we have a column and it says DF. That stands for degrees of freedom. Our T star is based off of our confidence level as well as our degrees of freedom. That's how we find what our T star is. Now, what is a degrees of freedom? Our degrees of freedom, DF, is equal to n minus 1, where n is our sample size. So I have a little practice for us down here. Okay, I have a couple that we'll do together. When n is equal to 10 and I want a 90% confidence interval, so I'm going to construct that. What is my T star going to be? Well, we know our degrees of freedom is n minus 1, so I'm going to take 10 minus 1. I have my confidence level of 90%, so 10 minus 1 is 9. That's my degrees of freedom. I'm going to go to my chart. My degrees of freedom of 9 is right here. So one of my T stars will be right here, or the T star will be in this row. How do I know what T star it's going to be? Well, if I want a 90% confidence interval, I go to 90%. I scroll up and I see that it's 1.833. Let's practice again. What if n is equal to 20? What's our degrees of freedom going to be? Our degrees of freedom are going to be 19. I want to construct a 95% confidence interval this time. So 95% is right here. Degrees of freedom of is 19. 95%, 19 degrees of freedom, 2.093. If that went too fast for you for these two, I want you to rewind, watch it again to see how I did it, because the next one's going to throw a little bit of a curveball at you. N is equal to 50. We have 99% confidence. Our T star we need to figure out. Our degrees of freedom is 49. So if I go to my degrees of freedom, sorry, I'm talking too fast. My degrees of freedom column here, you should notice that 49 is not there. What am I going to do then? Even though 49 is closer to 50, we always round down, okay? We always round down. So we're going to use the degrees of freedom of 40, okay? Use the degrees of freedom of 40. So 40 is right here. One of my T star will be in this row. I want 99%, so 2.704 is my T star. Okay, so what should we have gotten from this page of notes, you guys? We should know what our formula is for our confidence interval. It is our X bar plus or minus our margin of error, which is right here. We should know how to find that T star, okay? We should know what's happening. If our degrees of freedom is not on the chart, we need to round down. Finally, I want you to notice one more thing. As we increase our degrees of freedom, so that's essentially as we're increasing our sample size, what do you notice? Like, look at our degrees of freedom of 1,000, okay, compared to infinity, which is our Z star. As we increase our sample size, you guys, our T distribution approaches the Z distribution. Our T distribution approaches the Z distribution. I'm going to talk more about that when we do a one sample t-test for you. I'll get into the curve a little bit more, but that's something that you should write down and highlight. As we increase our sample size, our T distribution approaches the normal distribution, the Z distribution. Okay, this was the first video. The next video will be me going through a couple examples of T intervals. Let me know if you have any questions, guys.